Welcome to WakeTech's Chem 152 video series. This video regards boiling points and intermolecular forces. Our question for this video says to rank the following compounds in order of increasing boiling point. CH3CH2OH, and then CH3COCH3, then CH3CH2CH3, then CH4, and then lithium chloride. What we must first realize is that any question regarding boiling point automatically is also regarding intermolecular forces. With that in mind, let's go over the intermolecular forces you'll be expected to know for Chem 152. The first intermolecular force I'll cover is the ionic force. Now, ionic force is very strong and occurs in compounds with both metals and nonmetals in them. So any compound such as sodium chloride or table salt, sodium would be our metal, and chlorine would be our nonmetal. The next strongest intermolecular force you'll need to know about is hydrogen bonding. This is not as strong as ionic, but it is still fairly strong. Hydrogen bonding will occur in any compound that has either oxygen directly connected to hydrogen, or nitrogen directly connected to hydrogen, or fluorine directly connected to hydrogen. This must be a direct connection only. The third type of intermolecular force is the dipole-dipole interaction. This is not quite as strong as hydrogen bonding in most cases. Dipole-dipole interactions occur in any molecules that are polar. If you're taking Chem 152, you most likely covered the definition of a polar molecule in Chem 151. For the purposes of this course, try to remember two things at the foremost of your mind when thinking about polar molecules. You're looking for highly electronegative atoms, and looking for molecules that are not symmetric. Of course, you'll need to draw the Lewis structure in order to verify whether it's symmetric or not. We'll go over how to draw the Lewis structures of these molecules above in a moment. Before that, we'll go over the fourth intermolecular force called dispersion force, also known as London force. Now, we have to remember that everything has dispersion force, but not everything has it equally. Molecules that are higher in molecular mass tend to have much more dispersion force. Now, dispersion force tends to be fairly small and only matters much when you're talking about very large molecules. Before we begin ranking these compounds, we'll start by drawing the Lewis structures. We'll begin with the first compound in the list. We'll start drawing it from left to right, beginning with the CH3. C will go in the middle, and we'll connect 3 H's to it. This CH3 will be connected to a CH2, that's C with 1H here and 1H here, one above, one below. Then connect that to O and connect that to H. The next structure is fairly similar, except for there's a CO in the middle. We'll start by putting the first carbon, 3 hydrogens connected to it, then connect to another carbon. Bear in mind that this CO group is drawn as C double bonded to O. So if you see that in any of your own work, Remember that CO means C double bond O. Then connect this to our last CH3 carbon connected to 3 hydrogens. Our next structure is CH3, CH2, CH3. Fairly similar to what we've drawn previously. A carbon with 3 hydrogens, connected to a carbon with 2 hydrogens, connected to another carbon with 3 hydrogens. Our next structure is CH4, that's 1 carbon, connected to 4 hydrogens. Our last structure is LiCl. We'll just draw that with Li next to Cl. Once we've drawn all of the Lewis structures, we'll check our structures for those 4 intermolecular forces, starting from the top and working our way to the bottom. The reason we do this is because the highest strength intermolecular force is ionic, the next highest is hydrogen bonding, the next highest is dipole-dipole, and in almost every case that you'll see in this course, dispersion will be the weakest. We'll use dispersion as sort of a tiebreaker if we don't find any of the other forces. Let's begin with ionic. Recall that for ionic bonds, we are looking for metals connected to nonmetals. In these compounds, almost none of the atoms we see are metals, because in most of these compounds we have carbon, hydrogen, and oxygen. The only metal we find is located here. That's lithium. And then the chlorine is a nonmetal. And for that reason, we know there's ionic force in the LiCl. Now, ionic is much stronger than anything else, and so that will have the highest boiling point. We'll label that with a number 1. Next, we'll look in these compounds for hydrogen bonding. Now, recall that for hydrogen bonding, we are looking specifically for O directly connected to H, N directly connected to H, or F directly connected to H. In the first 2 compounds, you can see that both of them have oxygen, but only one of them has O in a direct connection to H. The other compound, to the right of it, has an oxygen, but that oxygen is not directly connected to H. Because of that direct O to H connection in the upper left compound, we say that this upper left compound has hydrogen bonding. We'll label this with a number 2. Next, we'll move on to dipole-dipole interactions. To detect dipole-dipole interactions, we are looking for electronegative atoms in compounds that are not symmetric. Now notice the 2 compounds that we haven't touched down here in the second row have only carbon and hydrogen. And from Chem 151, we know that carbon to hydrogen is not a polar bond at all, and that carbon is not particularly electronegative. However, in the compound in the upper right, notice we do have an oxygen. Now, if carbon's connected to oxygen, we'll have to remember that oxygen is one of our electronegative atoms, and it likes to steal electrons off of carbon, or really any of its neighbors. So you can think of oxygen as being electron-rich, and its neighbor carbon as being electron-poor. And so if you are electron-rich, you will be partially negative, which we abbreviate with a little d symbol and a negative. And if you're electron poor, you will be partially positive. To represent that more of the electrons are being pulled toward the oxygen, we'll symbolize it with an arrow with a plus symbol that's next to the partial positive, and an arrow that points toward the partial negative. This represents that electrons are being pulled upward toward oxygen. This also means that the oxygen's more negative than everything else, and anything that has a positive side and a negative side is a dipole. That's the word we use for any compound that's negative on one side, positive on the other. That is the next strongest after hydrogen bonding. We'll label that with a number 3. We have 2 compounds left, so now we need to look at the last force, dispersion. Recall that for dispersion forces, we are looking at whichever one has more mass. If we look at the compounds that we haven't looked at, if we look at these 2 compounds, we can see the first compound has 3 carbons and 8 hydrogens. The second compound has only 1 carbon and 4 hydrogens. We can tell just from the formulas that the C3H8 has more mass. And therefore, because it has more mass, it also has more force. It's important to realize it's not that much more, but it's enough to make a difference. Now that we've ranked our compounds, let's answer the question as written. We've been asked to rank the compounds in order of increasing boiling point. When they say increasing boiling point, that means to start with the lowest boiling point. Our lowest boiling point came from CH4, which is less than CH3CH2CH3, which is less than CH3COCH3, which is less than CH3CH2OH, which is less than LiCl. So if you wish to write the answer in the proper order in inequality form with the less than symbols. Thank you for watching. We'll see you again soon.